All right, guys, our second day of 8-8 to classify quadrilaterals. And today we only have like 4 questions to answer, but they're really important and they're going to take us a little while to explain. So I just want to show you what I've got. So somewhere in your SAB, you've got this little sort and classify quadrilaterals page. And I'm not going to ask you to sort and classify them, but I wanted to at least give you some opportunities to look at this to try to be able to figure out what kinds of quadrilaterals these are. So before I do the stuff on the left, I just want to walk through this one first. If I were to look at a shape like A, my job is to ask myself some questions about this quadrilateral. So first of all, does it have 2 sets of parallel sides? Well, that answer is yes. So this is a parallelogram, but then I have to ask myself if I can get more specific than that. Does it have 4 right angles? Yes, it does. Does it have both opposite or all 4 sides being the exact same length? Well, no, it doesn't. So that's where I stop myself and I can tell that this shape is a rectangle. Now you're able to look at that and know it's a rectangle, but these are just ways to make sure that you know for sure. A rectangle has 2 sets of parallel sides. It has 4 90-degree angles, and its opposite sides are the same length, not all 4 sides. Okay, so then we look at a shape like B. Well, okay, does it have 4 sides? Yes, quadrilateral. By the way, spoiler, these are all quadrilaterals. And then it says, or then you should ask yourself, does this have 2 sets of parallel sides? And the answer is yes. So this is at least a parallelogram. But now I need to ask myself a few more questions about its sides. Are all 4 sides the same length? No. Are there any 90-degree angles, or are there 4? And the answer is no. So parallelogram is actually the most specific name we could give this one. Okay, but then let's look at C. Does it have 2 sets of parallel sides? Yes, it does. Does it have 4 90-degree angles? No. But are all 4 sides the same length? Yes. So we would call this a rhombus. Okay. Think about D. Does it have 2 sets of parallel sides? Well, no. These 2 sides are not parallel. But does it have at least 1 set of parallel sides? And that answer is yes. So this would be a trapezoid. Okay? Because let's look at one like G. G is kind of a little bit different. G has 4 sides, so it's a quadrilateral, but it has no parallel sides. So does anything with no parallel sides have a more specific name? No, it does not. This is just simply called a quadrilateral. Okay? And then the last one we haven't totally talked about yet, I realized I spelled parallelogram wrong, is J. J is a good example of the last one that we haven't identified. It has 2 sets of parallel sides. It's got 4 sides that are all the same length, and it's got 4 90-degree angles, so we would call this one a square. Okay? So let's look at these true or false relationships here, although they are all true. So they basically want you to tell me why each statement below is true. And they don't give you a ton of room to write, but I am going to ask you to write a little bit today so you can make sure that you understand exactly why it is that these are true, because these are kind of tricky. I'm actually even going to make my line a little thinner so when I write, I have more room. So, like I said, all 3 of these are true, and you're going to write down a little quick statement about why it is. So the question says, or the statement says, a rhombus is always a parallelogram, but a parallelogram isn't always a rhombus. So think of our picture examples over here. This one was a parallelogram, and this one was a rhombus. So what's maybe the difference between the 2? Well, a rhombus, the definition of a rhombus is that it has to have 4 equal sides, but a parallelogram does not. So that's kind of what we're going to write here. We're going to say both have 2 pairs of parallel sides. I like to say sets. 2 sets of parallel sides. But to be a rhombus, it must have 4 equal sides. I'll give you a second. Although pause if I move on too fast. So both have 2 sets of parallel sides, but to be a rhombus, it must have 4 equal sides. Okay, I'm going to move on. Again, go ahead and pause if you didn't get a chance to write that all so you can finish that before I go on to look at question number 9. So this statement, which is true, says that a rectangle is a parallelogram, but a parallelogram is not necessarily a rectangle. So, for example, that would be like comparing A and B together. B is a parallelogram, A is a rectangle. So it's got two sets of parallel sides like a rectangle. But what makes something a rectangle is that it has 4 90-degree angles. Oh gosh, stupid hiccups. And my parallelogram doesn't have to have right angles. So here's what we're going to say for that one. Both have two sets of parallel sides. Both have two sets of parallel sides. But a rectangle must have 4 90-degree or right, doesn't matter, 4 90-degree angles. Please don't spell angles like angels. It's one of my teacher pet peeves. So angles is not with the L at the end. Angle has the L next to the G. Pause if you didn't get a chance to completely write down the answer to number 9, because I'm going to go ahead and move on to number 10, because I'm filming a 15-minute video. So oh, I blocked out the wrong one. That's funny. Okay, number 10. Watch me do a little TV movie magic here. I would like to unlock that, which I did. And I'm going to move that there, and then I'm going to lock that, and now you can see how I did that. Okay, so number 10 says a square. We're going to write this one in green, thin line. There we go. A square is a rectangle, but a rectangle does not have to be a square. So this time we are comparing, actually I'm going to compare these two together. Look at J and N on my screen over here. So N we can tell is just a tiny little bit longer, whereas J we can tell that all 4 are the same side. So this is the hardest comparison to make, but once you understand what's going on, I always like to think about it like this. In order for something to be a square, I have to have 3 different things to qualify to be a square. But in order to be a rectangle, I only have to have 2 things to be a rectangle. So in order for something to be a rectangle, it has to have 2 sets of parallel sides, and it has to have 4 90-degree angles. But the step further that we take to make something a square is that it also has to have 4 sides of the same length. So that's the biggest difference between the two. So a square can be a rectangle because it has 2 sets of parallel sides and it has 4 90-degree angles. It's just that it has a more specific name, which we call a square. So the definition I'd like you to write on this one is that both have 2 sets of parallel sides and 4 90-degree angles, because that's something that they both have. So again, both have 2 sets of parallel sides and 4 90-degree angles. But to be a square, all 4 sides must be the same. I guess I should say same length, but you get the idea. Okay, again, pause if you didn't get there, but I'm going to go ahead and move on. So the very last thing we have to do is this diagram, and I actually think this diagram is really helpful. It's a good visual representation of what we got going on here, but it's hard to fill out if you don't quite know how to fill it out. So we're going to fill it out together. And yes, I'm going to make you write all the words, and yes, I'm going to make you spell them all correctly because it's literally right up there at the screen, at the top of the screen for you. So we're basically going to build a Venn diagram, but a funky little math Venn diagram. So in your math Venn diagram here, it wants you to label a quadrilateral, trapezoid, a parallelogram, a rectangle, a rhombus, and a square. So what's the least descriptive name? What's the one that's like for any 4-sided shape? Doesn't matter how many sides, or it doesn't matter the length of the sides or anything like that. We just simply call that a quadrilateral. So the one that's the most basic should be the one that's on the outside of everything else, and that would be this line right here. Oh my gosh. So this is where you're going to write quadrilateral. With your pencil, it might be a little easier to fit on the page, but who knows? So that's telling me, just like in a Venn diagram, that's telling me that anything inside of this box is considered to be a quadrilateral, which we already know to be true. Quadrilateral is just anything with 4 sides. And it has 4 angles. So the next thing that we have to think of, we have all these things that are sort of related together, but then we have one that's off all by itself. And I want you to think about the one that didn't really fit the mold for anything else. And my guess is you'll probably think about your trapezoid. So trapezoid will be the next thing that we're going to label right out here. Now think about why it's over there. The reason it's over there, you don't have to write this down, but it's because it only has one set of parallel sides. And again, it's okay that you did not write that thing down over there. Now, when I look at the rest of these all have 2 sets of parallel sides. Now, because of that, I know that I am going to be able to lump these all together, but I have to be careful. What they're showing me is that there's some similarities between a couple of these, and that there's one that has absolutely everything. Now, my guess is you're already starting to think outside the box a little bit about what can go inside of these circles. And I know for me, if you think about it, whatever you write down in here is going to match for all of these. So if I were to write down square, for example, right here, well, a rhombus isn't a square because a rhombus doesn't have 4 90-degree angles. So I can't put square right here because it doesn't represent everything that's going on inside of here. But what does represent everything that's going on inside of here is the fact that they are all parallelograms. Oops. Get out of here, eraser. Parallelogram. Because a simple terms, a parallelogram just has 2 sets of parallel sides. Doesn't matter any of the other stuff. I should say. Okay, so now we've got left over a rectangle, a rhombus, and a square. So think about what I just told you a few minutes ago. Your square is the thing that has all of the requirements. It has to have 90-degree angles. It has to have 4 sides. It has to have 2 sets of parallel sides. It has to have sides that are all the same length. And I think there's one I'm missing, but I can't remember what it is. So a square has to have all of that stuff. So because of that, we put that square right in the middle because it's the most descriptive of all the names. But there's something that's in common with a square, and that would be both a rhombus and a rectangle. So we're going to write those in first. Rhombus is going to go here, and rectangle is going to go right over here, although it doesn't actually matter where you put which one. And then I want to tell you why these overlap the way that they do. So a rhombus, which is a parallelogram, which is a quadrilateral also, a rhombus has 4 sides that are all the same length, just like a square. And a rhombus has 2 sets of parallel sides, just like a square. Well, a rectangle has 4 90-degree angles, just like a square, and a rectangle also has 2 sets of parallel sides, just like a square. So these all kind of flow together in this way of your Venn diagram. So there you go. Hopefully that helps you today when you do your other work. My big ask of you today is to actually do your homework and remembering pages. I would love to see you do that. However, your IXL is also totally an option, but your SAB pages are all done, so that's definitely not an option. And just a reminder while I have you here, tomorrow when we do math, we are skipping 8-9. It's not a part of your curriculum, so we just skip 8-9. Just a heads up, okay? Good luck!